didn't have enough variables for the amount of things we were trying to figure out, okay? So you need to address the fact that this is the slope tangent to a point on the curve, and we're going to use this point because it's on this line that has other coordinates that we know something about. Okay? So we know that slope is equal to difference in y's, and so I'm going to use these 2 points to write out the expression of slope. So y1 minus 0 over x sub 1 minus negative 5 is plus 5. And so keep in mind, y sub 1 and x sub 1 are a specific point on the curve, whereas this x and y are generic. But this expression should give me the same slope as taking 2 points that I know are on the line. So I do want to replace this with, so like at that point, this expression should give me the same slope as calculating the slope between those 2 points. Okay, so these x's should be the same x, and these y's should be the same y's. All right, so now that I have that equation, I'm going to cross multiply. I mean, basically, I want to try to do something with this equation. I'm going to choose to cross multiply. So I'm multiplying negative x times that expression, and it'll give me this. And then I will get 4y1 squared, and then the 0 we can ignore. So then that can be written as negative 5x sub 1, 4y sub 1 squared, plus x sub 1 squared. And, hang on, I'll back up for a minute. If you notice, this matches that form. So because I know this point is on that ellipse, and this is the equation of the ellipse, then this should equal 5. Okay, this equation tells me that every point on this ellipse satisfies the condition that x squared plus 4 times y squared equals 5. So this point's on that ellipse, so its x squared plus 4 times its y squared should equal 5. So I get negative 5x sub 1 equals 5, which means the x coordinate of that point has to be negative 1. So where the line is tangent to that curve has to have an x coordinate of negative 1. And from that, we should be able to figure out the y coordinate, because we've got a couple of different equations. I'll just use the actual equation of the ellipse. Okay, so 1 plus 4y1 squared equals 5. So 4y1 squared equals 4. So y1 squared equals 1. So y equals plus or minus 1, but the point we're looking at is positive, so y equals 1. So that point is minus 1, 1.
So basically down here at the bottom, you just replaced the equation with what it equals, correct?
Correct, right.
Okay.
Well, yeah, I mean, basically, I replaced this with 5.
Because it equals, up there it equals 5.
And I know the point I'm talking about is on the ellipse, and every point on the ellipse, that's true.
Right.
Okay, so from there, I don't know, there's a number of things we could do, but one, we can figure out the slope of that line. Okay, so I mean, the slope of the line is the slope between these 2 points. So 1 minus 0 over negative 1 plus 5 equals 1 over 4. Okay, so the slope of the line is 1/4. But then that slope should be the same as the slope between these 2 points. So if the slope between these 2 points is 1/4, the slope between these 2 points should also be 1/4. And so h minus 1 over 3 minus -1 is plus 1 should equal 1/4, and we should be able to solve for h. Okay, so what I'm doing here is I'm doing slope formula, but now using the point at the lamp with this point right here. You could also solve a similar equation and get the same answer if you use the point with the lamp and that point. Okay, we now have enough information that I can reason out the h. Okay, so I just did
Gotta be two,
h
right?
minus 1, 3 minus -1, and we know that the slope is supposed to be 1/4.
Oh, you just gotta be two.
So h minus 1 should equal 1, because 3 plus 1 already equals 4.
So H should be two.
So h should be 2. And that's what we were, the height of the lamp should be 2. So whatever units, I don't know, meters, so 2 meters, would maybe make sense, I don't know. That
It's
still
not a short
seems pretty
lamp.
low.
It's a
Hitting
short
some people in the
lamp.
head. I don't know, they didn't give us units, so. All right, so anyway, that was that problem, that the